Hey everyone, welcome back to the channel. Ever wondered why your computer suddenly slows to a crawl? The fans spin up like a jet engine and everything just feels sluggish? The culprit is often high CPU consumption, but what does that even mean? Today, we're diving deep into the heart of your computer to demystify the CPU, understand what eats up its power, and learn how to tame the beast. This is your complete guide to CPU consumption. Let's get started. First, let's pull back the curtain and look at the technical mechanics. What is actually consuming your CPU's resources? At the lowest level, it's a constant dance of tiny operations. We're talking about interrupts, which are signals from hardware or software needing immediate attention. Then there are kernel-level operations, the fundamental tasks your operating system performs to manage everything. Every time a program needs to access hardware, like your storage drive, it makes a system call. This forces the CPU to switch from user mode, where your applications run, to kernel mode, which has full system access. This context switching between modes, though fast, adds up and consumes CPU cycles. It's like a manager constantly being pulled away from their main task to answer phone calls. Now, think about modern computing. We do tons of things at once. This is where multi-threading comes in. A single application, like your web browser, can run multiple threads simultaneously, one for rendering the page, one for playing a video, another for running extensions. While multi-core processors are designed to handle this, juggling these threads, a process called context switching, still requires CPU overhead. And don't forget cache misses. The CPU has a small super-fast memory called a cache. When the data it needs isn't there, it has to fetch it from the slower main RAM. This delay, this cache miss, leaves the CPU waiting and wastes precious cycles, effectively increasing the load. So what happens when CPU usage skyrockets? What's the real performance impact? The most immediate effect is latency. Everything takes longer. Mouse clicks feel delayed, typing lags, and applications become unresponsive. In gaming, this translates to stuttering and low frame rates, making the experience unplayable. A system with high CPU usage isn't just slow, it feels broken. It's important, though, to distinguish between a CPU being a bottleneck and a CPU that's just waiting. If your CPU is at 100% and your game is lagging, the CPU is the bottleneck. But if your CPU usage is low while a large file is loading, it's likely waiting on your slower hard drive. That's an I/O bottleneck, not a CPU one. Finally, there's the heat. A CPU working hard generates a lot of heat. If it gets too hot, it will engage thermal throttling, intentionally slowing itself down to prevent damage. So, sustained high usage can ironically lead to even worse performance as your CPU protects itself. Now, let's identify the usual suspects. Who are the main consumers of your CPU's power? We can group them into three categories. First, system processes. This is the overhead of your operating system just running itself, managing Windows, networking, and security. It should be relatively low on a healthy system. Second, applications. These are the programs you actively use, from demanding video editors and games to your web browser with 100 tabs open. Third, background tasks. These are the silent resource hogs, automatic updates, antivirus scans, and file indexing services that run without you even knowing. To manage this chaos, your OS uses tools like process priority and CPU affinity. Priority tells the OS which tasks are more important, while affinity can pin a process to specific CPU cores, which can sometimes improve performance by optimizing cache usage. That's why tasks like video encoding, compiling code, or calculating complex physics in games are so CPU intensive. They involve a massive number of mathematical calculations that have to be crunched by the processor. So, how can you, the users, see what's going on and actually fix it? Your best friends here are tools like Task Manager on Windows or Activity Monitor on Mac OS. These utilities show you a list of all running processes and how much CPU they're using, typically as a percentage. Percentage usage tells you how much of your CPU use as total capacity is being used at that moment. You might also see a load average, which gives you a sense of the CPU demand over the last 1, 5, and 15 minutes. A high sustained percentage for an app you're not even using is a huge red flag. What's the fix? For software, the first step is to identify and terminate the misbehaving process. Sometimes, simply restarting the app or your computer will do the trick. For long-term solutions, look into optimizing software settings, disabling unnecessary startup programs, and scheduling background tasks for when you're not using the computer. On the hardware side, if you're constantly hitting 100% CPU on demanding tasks, it might be time for an upgrade. A CPU with a faster clock speed will perform calculations quicker, and more cores will allow you to run more tasks simultaneously without slowdowns. And that's our deep dive into the world of CPU consumption. From kernel-level operations and context switching to thermal throttling and process management, you now have a much clearer picture of what makes your digital world tick. Understanding the why behind a slow computer is the first step to fixing it. Hopefully, these insights will help you diagnose issues and keep your machine running smoothly. Thank you so much for watching. If you found this video helpful, please give it a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next Tech Explicable. If you have any questions or topics you'd like to see covered, drop them in the comments below. Until next time, stay curious.